We know statistics is the collecting, organizing, and analyzing of data. And when we collect data, it is impossible for us usually to collect data from an entire population. And so what statisticians do is they'll take a sample of data, as long as it's a random sample, and they'll make predictions of what they think is going to happen with the population. So I have an example of how that would be done today. So say we have this problem. A survey of 200 randomly selected dog owners finds that 130 out of the 200 dog owners prefer brand A dog food. Predict how many dog owners in a town of 1,500 people would also prefer brand A. Now, I'm not going to go to the town of 1,500 people and ask them the same question. Statisticians never do that. They use math to make a pretty accurate prediction of how many would respond to that. So how do we do that? Well, we create an equation. And on one side of the equal sign, it's the number of predicted people out of the whole town. What do we think out of that 1,500? How many people are going to prefer dog food A? Now on the other side of that equal sign, the way we get our prediction is we find the percent of people that liked brand A in the sample, and we multiply it by the total number of people in the population we want to do. So let's break this down. I know 130 people out of the 200 people that were randomly sampled said, yes, we like brand A. So I'm going to take 130 divided by 200, and that gives me a decimal, which is 0.65, and I can change that decimal then always to 65%. So that's my sample percent. But we know that when we calculate in math, we never calculate in the form of the percent. We always calculate in the form of the decimal. So I'm going to take that 0.65, and now I have to multiply it by the population of the town, the one that I'm looking for. So I know the town has 1,500 people. So if I want to know 65% of that town of 1,500 people, then when I multiply that, I see that that's 975. Now, what does that mean? It means if that 65% held true from the sample, then I could probably make a pretty accurate guess that 975 dog owners are also going to like the brand A out of the 1,500 people. Now, we know that this was a randomly sampled group of people that answered that question. If I took a different group of people and I asked them the same question, I'm not going to get exactly 130 out of 200 every time. It's going to vary. And so what statisticians do is they have something called margin of error. And what they're thinking is, okay, if it was a slightly different group of people I asked, I'd have a slightly different response. And so they usually go up and down from that original percentage. And so the way we look at this, they'll say, oh, there's a margin of error of plus or minus 5%. Well, it means that if it was minus 5% in any other sample, then I could take 5% away from the 65, and that might be 60% of the people would say, yes, I like brand A. But it could be in another sample that actually more people like brand A. And so they're going to say it could go up 5% higher. So if I take 65 plus 5%, then I get 70%. So there's a range of people that we can predict are going to like brand A. So the range would be anywhere from 60% would be 900 dog owners, 70% would be 1,050 dog owners. So if I were the manufacturer of dog food brand A, in that town alone, I could pretty much guess that either between 900 to 1,050 of those dog owners out of the 1,500 dog owners are going to like my food. Somewhere in between there, it should work. So when we're looking at statistics, it's not always that it's one exact number. It's usually a span of numbers that we can make some guesses for, because that really is what statistics is doing. We're making guesses about what we think is going to happen. So your job today is to be able to make predictions to a larger group of a population from a sample that we take. So follow this equation. It works every single time. I know you'll do well. Good luck.